In this video, we will discuss how to solve triangles that are not right triangles, and we're going to have to use things other than a Pythagorean theorem or some other method. For the first part, we see that we have something called the Law of Sines, and we have the Law of Cosines. And the Law of Sines would be a series of different proportions that you would set up and solve. You would only need to set up two of these three, and it can be any two of the three. Now, when you will use this depends on what you're given. From geometry, you talked about having an angle, side, or you also talked about angle, side, angle. And that's going to be, of course, when you're given two angles and one side. Then using the law of sines would be a good place there. The other one would be if you had side, angle, and that's going to be whenever you had two sides and one angle. For the law of cosines, and you can use any of these three particular formulas, just depending on what you're given. And this is usually whenever you have side, angle, side, which again would be two sides and one angle. But again, it would have to fall under the side, angle, side. The other would be when you're given side, side. In other words, you just have your three sides given to you. Then you can use your law of cosines to solve those triangles. So in example 1, if you'll notice, you are given angle, and side. So angle, side, that means you're going to need the law of sines. And to see how that's going to work, we're going to set up a ratio of our sides. I know that sine of 31, and so I'm going to start with sine of 31, and the denominator of that is going to be the side opposite, so that's going to be 14 feet, is equal to sine of 36 over this missing side over here, which is going to be AB. And so to solve for this, we're going to cross multiply. So I have AB times sine of 31 equals 14 sine of 36. And then we'll divide both sides by sine of 31. And all of that needs to go in the calculator. Do make sure your calculator is set in degrees. And then once we've solved this and rounded, we see that side AB is going to be equal to 16. Now we're going to use very similar situation here to solve for the other sides. So again, now please don't try to use the Pythagorean theorem here. This is not a right triangle, so that's why we're having to come up with a different way to solve for these values. So looking over at the other side, well, we need to find AC, side AC. So this one we're not given, but we can also set up another ratio and do use the ratio that you're given. So again, we would start out with sine of 31 over 14 is equal to, now I need to solve for this side here. Now we don't have that side given to us, or we don't have that angle. But since we already have two angles, I know that that sum of all three has to be 180. So we can go ahead and solve for that missing angle. We know 31 plus 36 plus angle B has to be equal to 180 degrees. So once we solve for that, we're going to see that angle B should be equal to 113 degrees. So now that we have that angle, we can go ahead and say that sine of 31 over 14 is equal to sine of 113, which that's our angle, over that missing side. And so now we can do our cross multiplication. We can say x times sine of 31 is equal to 14 times sine of 113. And again, divide both sides by sine of 31. And now we see that that side, and I know I called that side x, but that side is going to end up being side AC is going to be equal to 25. So again, side AB was going to be 16. Get my pen to work. 16, side AC was 16 feet, is 25 feet. And we found angle B to be 113 degrees. All right, now moving on to our next problem. And again, look at what you're given and see if you can determine what we need to use first. And on this one, it looks like we have a side and we have an angle and side, angle, side. So that tells me we probably need to use the law of cosine. And the way you're going to figure out which side is going to be the missing part or that beginning, so from here, this side across here, and let's call that's going to be little r. So that can be our side that we're going to have to start out with. So setting up your law of cosines, you're going to have r squared equals one of your sides squared plus the other side squared minus 2 times the product of those two sides times cosine of your given angle, which is 87 degrees. And again, you can type every bit of this in your calculator. So all you would need to do to solve for this would be to take the square root of both sides. So in your calculators, and do make sure all of this stays under that radical. That way you don't mess up anything. And don't try to shorten it. Normally kids try to combine the 28 squared, 17 squared, and the 2 times 28 times 17. If you're going to choose to do that, you're going to have to also multiply here by cosine of 87. All of this is one big term, so don't try to separate that. So that side R looks like it's going to end up being approximately 32 kilometers. So we've found side PQ, which is going to be 32 kilometers. And now we can repeat this process, or we can set up a ratio and try to solve for our other angles. And I would try to set up that law of sines in order to find that, because the law of sines is a little bit easier to work with. So setting this up, we have to decide what angle we're going to solve for. And so I would say that we are going to solve for angle P. That'll work. And so here setting up, I know side R is now found to be 32. And so we're going to use that in setting up our ratio. So I'm going to say sine of 87 over 32 is going to be equal to sine of angle P over 28. And again, you're going to do your cross multiplying. And so here you're going to have 28 times sine of 87. That's going to be equal to 32 times sine of P. We are going to divide both sides by 32. And now we've got to solve for angle P. And this is where we did our inverse function. So we're going to have to move sine all the way over here. And when you write this or type it in your calculator, it is the inverse sine of all of this other side. So make sure everything gets typed in the calculators correctly. That's going to give you the value for angle P. And if you type all that in correctly, it looks like you should get about 60.9 degrees. So here we have found angle P with 60.9 degrees. And then we can add up and subtract from 180 to get our other angle. And if we do that, then that's probably going to leave us 32.1 degrees for angle Q. Okay, in example 3, we are not given a triangle that has already been labeled. So we're going to have to go through and use the given information to somehow set up a triangle. Now, this triangle is not going to be a right triangle, so do keep that in mind as you're sketching through making that triangle. So, again, do not make a right triangle. Okay, so now let's go through and label, and how you choose to label it will be up to you. As long as you stay consistent with the given information, you'll be okay. So I'm going to start down here. We have angle D, E, and F. And then notice the side values that you're given. They're telling us that DE is 6. We're also given that EF is 14. And then DF is going to be 18. So this is a situation where you do have side, 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 which means you need the law of cosines. Now, with law of cosines, where you start is very important. You have to always start with finding, if you're given all these sides, you have to find the largest angle first, and that's going to keep us from getting into some cases that will not exist. You can always eliminate that by finding the largest angle first. Now, I circled angle E because it is across from the longest side, so I know that is the largest angle. So that's where I need to start. So setting up the law of cosines, again, our missing angle is what we're going to be ending with. So we need to start with the side across from that. So I have 18 squared equals 14 squared plus 6 squared minus 2 times 14 times 6 times cosine of the angle, and I'm just going to call it angle E. Alright, so be careful with the algebra. Again, this entire part is one whole term. So we can subtract over this other information, or we can go ahead, let's see, 18 squared is going to give us 324, and we can go ahead and find 14 squared plus 6 squared. You're more than welcome to combine those terms. That should give you 232 minus, you cannot combine that 232 with any of these other numbers. Now you can multiply these, and that's going to give you 168 cosine of angle E. Now you do need to subtract your 232 over, and that's going to leave you with 92 equals negative 168 cosine of angle E. We are going to divide both sides by negative 168. And again, here, that ratio there is not going to be your final answer. You're looking for angle E. So cosine is going to have to be moved over to the other side. So you have inverse cosine of 92 over negative 168. And that's what you're going to type in your calculators. And so the measure of angle E should be 123.2 degrees. Now that we have angle E, then we have really where we can set up our law of sines, because we have a side and an angle to match. So let's see, we can go ahead and I would find the next largest angle, and that's probably going to be, well, we can find, no, let's find the smallest. And again, that's going to keep us from having all these strange cases that we don't want. So to go to finding the smallest, then again, we're going to set up the same law of sines that we did earlier. We're going to say sine of 123.2 over that side opposite, which we were given is 18, that's going to be equal to sine of angle F over 6. And then you can cross multiply, so you have 6 times sine of 132.2. And that's going to be equal to 18 times sine of F. Divide both sides by 18. And then finally, again, you're solving for angle F, so sine needs to be moved to the other side, and you can put every bit of this in your calculators. You're going to have 6 times sine of 132.2 all over 18. That's going to be equal to angle F. And whenever you put all of that in your calculators, you should get 16.2 degrees for angle F. And then you can add up your other angle and subtract from 180 to get that final. And so you should end up with 40.6. And again, the first one we found was 132, or 123, sorry. 0.2, and angle F was 16.2 degrees. Okay, the next example, again, start out with drawing a triangle of what you're given. So, and again, do not make that triangle a right triangle. Alright, and so labeling all of the information you're given, however you wish to go around and label it is up to you. I'm going to do WXY, and again, label the sides of your triangle as the information is given to you. So we see that side WX, that's going to be a 9. XY is 15, and angle W is 31. So on this one, notice that you are given an angle and side or side angle. So that means you can go ahead and set up your law of sines and try to find some of this information. Now, you would be able to use sine of 31 over 15. So let's go ahead and start that part. You have sine of 31 over 15 is going to be equal to, and then solving for the next, we can do y, angle y, and then that's going to be across from side 9. So sine of y over 9. And again, you're going to cross multiply, so you have 9 times sine of 31 equals 15 times sine of y. We're going to divide both sides by 15, so we have 9 times sine of 31 over 15 equals sine of y. And again, we're looking for angle y, so we need to move that sign. So that's going to be inverse sine of 9 times sine of 31 all over 15. That's going to be our angle y. And once you put all that in the calculator, it looks like you should end up with 18 degrees. Alright, so now we know angle y. That is going to be 18 degrees. Now we can go back and solve for, we could do the side across from angle, or the side across from, which one could we do? Here, let's find that one across from 15 or x. Either one of those would be fine. There's not going to be a general case there. So let's see. Let's go ahead and set up. We can find angle x. Let's go ahead and do that because we just found angle y. So that's going to make that a little bit easier. Let's find angle x. Add up what you're given, subtract from 180, and it looks like you're going to end up with 131 degrees. So now we have that largest angle. Now we can find the longest side. And that is what was concerning me. I did not pay attention that we had that other side, or that other angle. Alright, so now let's set up the law of cosines. So we're going to have that longest side squared, and I'm just going to call that side y, equals, we're going to have 9 squared plus 15 squared minus 2 times 9 times 15 times cosine of that angle we just found, or 131 degrees. And you can put all of that in your calculators. Do make sure it's all under the square root function, and you don't have to multiply anything out on this one. Let that calculator do it for you. And hopefully we will get, for our side, 22. Okay, for our first application problem, let's go ahead and draw our triangle. And again, these triangles are not going to be right triangles, so be careful when sketching those. Now, the first part, we're told that Cincinnati, Ohio is 540 miles due east of Kansas City, Missouri. The bearing from Kansas City to Nashville, Tennessee is south 64 degrees east. So here, let's go ahead and label just that information there. So Kansas City would have to be over here, and the distance from Kansas City over to Cincinnati is going to be 540. Now notice that the information about Nashville, Tennessee is south, and it's 64 degrees east. So I'm going to put Nashville down here. But when we're talking about bearings, we have to be careful with that. And I'm going to go ahead and put in this dotted because the bearing angle is really complementary to the angle that we need. So do keep that in mind. And true north is going to be up at 90 degrees. So be careful with that as well. So notice that we were told that Kansas City to Nashville, Tennessee is south and 64 degrees east. So that's really telling me that this angle inside here, that is your 64 degrees. And so if that's your angle on the inside, then the complementary to that is going to be inside here, which is going to give us 26 degrees. And then, let's see, we have some more information. The bearing from Cincinnati to Nashville is south and 29 degrees west. So that's going to tell me that I have 29 degrees here. That's your bearing. And then that's also going to be complementary to this angle inside here. So that's going to give me 61 degrees. And now I think we have just about all the information we need. I think we could go ahead and find that last remaining angle. If we add 61 and 26 and subtract that from 180, that's going to give us 93 degrees here. Alright, so the first question tells us to find the distance from Kansas City to Nashville. So from Kansas City to Nashville, we are looking for this side over here, Kansas City to Nashville. And I think we can set up our law of sines in some kind of proportion and solve that. So we know for sure that sine of 93 and the side opposite that is 540. So we have that for sure is equal to, and if we're looking for that side over there, then we're going to have to say sine of 61 is going to be over what we're looking for. And I'm just going to call that sine y. And now we're back to cross multiplying. Y times sine of 93 equals 540 times sine of 61. And dividing by sine of 93, we should get a side value of, and again, that's going to be in miles. It's a distance. So it's going to be 472.9 miles. All right, so now we have that side value. Look at part B. Part B wants you to find the distance from Cincinnati to Nashville. And so now we're finding a different side. We're looking at Cincinnati to Nashville. So I'm finding this side over here. So again, setting up our law of sines. And I would again start with what we were given, which was sine of 93 over 540. And now this time that ratio is going to be sine of 26 over that missing side, and I'm just going to call that one x this time. So we have x times sine of 93 equals 540 times sine of 26. And we are going to divide both sides by sine of 93 and get that in our calculators. And so that distance there is going to be 237 miles. All right, so for number 6, we're told that we have two ships that are leaving from the same port, and ship A sails 8 miles at a bearing of north 45 degrees west, and ship B sails 14 miles at a bearing of south 70 degrees west. All right, so of course, let's draw us a triangle. And in this triangle, again, make sure you don't have a right triangle, and it doesn't have to be perfect. It's just a triangle here. And I'm going to label here, I'm going to make this side here the port, just because I've got one ship that is sailing north and then one that's going west. So it'll be a little bit easier to draw what we need to from here. All right, so for that first one, ship A is sailing 8 miles at a bearing of north 45 degrees west. So that tells me here that A is going in that direction. Now we have to be careful again with this bearing. That's telling me that this angle out here, this is what our 45 degrees is. So we have that. And we know that side length is going to be 8 miles. So I'm going to put 8 here. Now for our other ship, ship B, and it is going, let's see, sails 14 miles at a bearing of south 70 degrees west. So I'm going to change colors here. And so from here, notice it's going south 70 degrees west. So that's going to tell me that this angle here, that's going to be our 70 degrees. And notice that it is going 14 miles. So here's that side. Now, what this is wanting to find from us, though, is to the nearest tenth of a mile, how far is ship A from ship B? So that's going to be this side over here, because ship B is over here. So we have A heading this direction, B is heading this direction. So I want to know, what is that distance? Well, if I had this angle inside here, then I could set up the law of cosines. And we have enough information to find that. I know from here all the way around is 180 degrees. So 70 plus 45, that's going to give us 115. And so 180 minus 115, that's going to give us, let's see, 65 degrees. So now we have that particular angle, that is 65 degrees, and we can now find that distance. So here we're going to have our law of cosines. The side is missing, that's what we're going to start with, is equal to 8 squared plus 14 squared minus 2 times 8 times 14, and then cosine of the angle we just found, which was 65. And so again, you can put all that in your calculators, and so the distance between the ships is going to be 12.9 miles. Now in part B, we're asked to find the bearing that ship A should take in order to get to ship B. Now we're going to use our law of sines here, and keep in mind with the triangle that we have, I'm just going to redraw that with some of our information, not everything we have drawn up there. But we already know this angle inside here is 65 degrees. We found that. And then we found that other side over here, the distance from A to B is 12.9 miles. So that's what's telling me that I can use our law of sines. And so there's ship A, here is ship B, and here's the port. So really we know this side is 14. And so if we're looking for our bearing, we really need this angle up here to help us find that. So the setup of this, we're going to have sine of 65 over 12.9 is equal to sine of A, which is what we're going to be looking for, over 14. And so cross multiplying, dividing, let's see, so that's going to give me sine of A is equal to 14 times sine of 65 all over 12.9. And when we do our inverse sine, when we move that sine over, then that angle is going to give me 79.6 degrees. Now we have to be careful because that's not necessarily the bearing that has to be taken. That's just saying that this particular angle right here is 79.6 degrees. So keep in mind here, we already knew from earlier that angle B was at a 70 degree bearing. That was given to us. If we knew this portion here, then we could probably line up and find the bearing that angle, or the bearing that ship A should take. So this remaining angle, if we add and subtract from 180, that remaining angle is going to be 35.4 degrees. So I already know ship A is kind of heading, if they want to head in that same direction here, it's already got, of that 70 degree bearing, it's got 35.4. So the actual bearing that ship A needs to take is going to be this difference, which is going to give us a south 34.6 degrees west. And that should get us over to ship B. Alright, and the last part of this lesson, we're going to go through and review the area of a triangle. So we know that area is going to be 1/2 base times height. And look at sine of angle C. Sine of angle C, notice it's going to be side H over A. Now if we solve for H, then I'm going to be multiplying this A over to the other side. And so H equals A times sine of C. And so really we can incorporate all of that into one big formula, and this is a formula that comes up on the ACT quite a bit. It's another way to find the area of a triangle, and it's going to be 1/2 AB times sine C. And that's going to be a real useful formula for you to know, especially on the ACT and in Math 113. So let's use our formula, and again, over to this side, let's remind ourselves that area formula was 1/2 AB times sine of angle C. And so if we were asked to find the area of each triangle, notice we don't have that height given to us, but we have plenty of information to actually find our area. So we're going to start out with our area is 1/2 A and B, and it doesn't matter which is which. So 16 times 11 times sine of 105 degrees. And notice once you work that out, put all of that in your calculator, your area is going to be 85 feet squared. All right, so over on number 2, again, same thing. So our area formula is going to be 1/2 AB times sine of that given angle. And put all of that in your calculators, and you should get 106.8 inches squared. Okay, in our next triangle, we still have to find the area. However, I'm not given quite enough information. Remember, that area formula was 1/2 times AB sine of C. So I don't quite have that. I have 2 angles on the side. So we do have enough information, though, to set up the law of sines. So I could say sine of 76 over 7 is equal to, and then we can go ahead and say that we have 59, sine of 59 over x. And so cross multiplying and solving here, we're going to have x is equal to 7 times sine of 59 over sine of 76. And so that side x is going to be 6.2, roughly 6.2. And now we have enough information to find our area. So that side's 6.2. So now we can say the area is going to be 1/2. And we have AB, so 7 times 6.2 sine of that angle of 45, which is that angle there. Add and subtract from 180. And so our area is going to be 15.3. All right, number 4, very similar, same idea here. Make sure again you have side, angle, side, and we almost do. We have angle, side, angle. So we have enough information, though, we can find our missing angle here, which is going to be 32 degrees. And now I think we have enough information. So we're going to set up our law of sines. So we're going to have sine of 32 over 13 equals sine of 22 over our missing side. And so cross multiplying and dividing, we have x equals 13 sine of 22 over sine 32. And so that side x is going to be 9.2. So we found this side right here is 9.2. And now I think we have enough information that we can go through and find our area. So that area is going to be 1/2, 9.2 times 13 times sine of 126. So that area is going to be 48.4 kilometers squared. All right, so for our next problem, we're missing an angle before we can do our formula. We have enough information in our formula. Notice we have 1/2, and then we have A, B, but I don't have sine of an angle C. So we're going to have to try to find that angle. So we're going to set up here again. We know that sine of 85 over 11 equals, and then we're going to have this angle here, so it's going to be sine of x over 5. So we're going to cross multiply again. So 5 times sine of 85. And then that's going to be equal to 11 sine of x. And so we'll divide by 11. And then move our sine value over and do our inverse sine. So that gives me an angle measure of 26.9. So that's going to be our missing value here, 26.9. And so that area is going to be 12.4 centimeters squared. All right, so this value down here, number 6, again, we're still looking for a value, let's see, our area. And keep in mind we have 1/2 AB sine C. Now, since we have side, 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 that's going to be your law of cosines. And so with our law of cosines, you always want to find the largest angle. And so that's going to be immediately across from the longest side. So there's our angle that we need in order to fill in our formula. So setting up that law of cosines, our side that we'll start with is the side across from the angle that we're looking for, equals 14 squared plus 6 squared minus 2 times 14 times 6. Cosine of that missing angle, we'll call it A. And so again, doing all the algebra stuff here, you will have, let's see, 16 squared is 256 equals, let's see, if we combine those together, you're going to have 232 minus 2 times 14 times 6, that's going to be 168 cosine A. And so subtracting over, dividing, you're going to have negative 0.1429 equals cosine A. And doing your inverse cosine, we're going to get that angle A to be 98.2. So that's our angle, 98.2. And so now we can plug into our area formula. So that area, again, you're going to have 1/2 AB, so 6 times 14 times sine 98.2. So that area, once you get all that typed in, should be 41.6. So next time you're given just all the different sides and nothing else, you really don't have to go through that law of cosines. We can do what's known as Heron's formula. Now, Heron's formula, again, is another way, if you know all 3 sides, and really it's a pretty quick way. We're going to have S times S minus A, and I'll go through and define what all these letters mean. But this is a super fast way to go through and find the area of a triangle when you're just given all the sides. And so S is going to be what's known as your semi-perimeter. In other words, you're going to do half of the sum of all 3 sides. So again, that's why we're calling this, it's really a good alternative to all the other stuff. And so again, remember that is the semi-perimeter. So just add up all the sides and take half of it. So here, let's look in example 7. And again, I would not want to go through the law of cosines again if we could help it. So the first thing you would need to do is find S. So that's going to be half the sum of 18 and 19 and 21. So that's going to give us 29. So now that area is going to be the square root of 29 times, and then go back and subtract your sides. 29 minus 18 times 29 minus 19 times 29 minus 21. And so putting all of that in your calculators, you're going to get the area to be approximately 159.7. And oh wow, this was in miles, so miles squared. All right, so for the last problem, number 8, it's going to be the same idea here. Notice that you have a triangular shaped piece of glass. You've got all 3 sides. They're all the same units, and it wants you to find the area. So again, find your semi-perimeter, which is going to be half the sum of all the sides. So 35 plus 27 plus 14. So your semi-perimeter is going to be 38. And so the area is going to be the square root of 38 times 38 minus 35 times 38 minus 27 times 38 minus 24, or 14, so that's going to be 24. And so when you put all that in your calculators, you're going to get 173.5 inches squared.